Fusion Mobile, quality e-learning experience on the go.
Hello and welcome to today's class. Our topic for today's class is caption quadratic equations. And we'll be talking of the four methods for solving quadratic equations. Okay. All right. There are four methods for solving your quadratic equation. The first method is the method of factorization, and I know we've treated this method in our quadratic one. And then the second method is the method of completing the square method. Okay. And then the third method is the one we call the use of formula. To solve a quadratic equation, the use of formulas. Okay. And then the fourth method is the graphical method. All right, in previous classes we've done two methods, the graphical method, we've done factorization, and so for this class we'll be considering quadratic equations using the formula method. We'll be solving using the formula methods, okay, and then by completing the square method. All right, completing the square method for the quadratic equations. Completing the square method. All right, how do we solve by completing the square method? All right, just don't forget that your quadratic equation looks like this: ax squared plus bx plus c. It is called an equation because it is equal to 0. All right, but if it just the expression of ax squared plus bx plus c, then you know it's just an algebraic expression. What makes it an equation is the equality sign and the 0 afterwards. Okay, so we call them quadratic equations because they have the highest index power. There is 2. Okay, 2 is the highest index power, and so we can say 2 raised to power 2 has the highest power. I mean every other variable is raised to powers. All right, and so we'll carry out solutions by completing the square method. Okay, there are steps that can help us solve quadratic equations by completing this method, and we'll solve by using examples. For example, if we are given to solve if you're given example 1, find the roots of the equation. All right, and the equation is given us 2x squared plus 5x equal to 3. Okay, this may not really look like if you observe the above quadratic equation, you find out that the only difference between it and the ones you used to know is that the constant 3 is after the equality sign, so you can do well to bring the constant 3 behind the equality sign, and then this becomes 0. Okay, 3 crosses an equality signs, it changes from positive to negative. All right, and so now we can begin to apply our steps. Step 1, just like we have done above. Step 1, you ought to observe very well. Observe the given equation carefully, okay, so that if there are rearrangements to be made, okay, you can make the rearrangements, and so that all the terms are on the same side of the equation sign, okay, on the same side of the equality sign. Okay, all right. Just like we had above, the first step is 2 plus 5x, and then moving 3 from that point to the other point, and so we have that 2x squared plus 5x minus 3 is equal to 0. And step 2 states that we make the coefficient of x, the coefficient of x squared, okay, make the coefficient of the term x squared unity. Okay, all right, all we are saying is that in this case, just like we have above, you can make the coefficient of x squared unity by dividing. You can make that by dividing throughout by 2. Okay, all right, throughout by 2. Okay, hence we have that's 2x squared over 2 plus 5x squared over 2 minus 3 over 2 is equal to 0 over 2. Okay, that's good. And so we have 2x squared over 2, 5x over. So when 2 divides, it gives 1, so it turns to unity. So assuming the coefficient of x squared here is 3, so that means we divide. The next step is dividing all through by 3. Okay, so that what we'll have is the outcome as x squared plus 5 over 2x minus 3 over 2 is equal to 0. So step 3 states that we rearrange the equation. Okay, rearrange the equation. Okay, so that the s squared, so that s squared and x terms will be on the same side, will be on one side of the equation. Okay, and then the constant will be on a separate side too. On a separate side. Okay, so which means we are just saying we should just group. All right, hence all we are saying is that we should group so that we have x squared plus 5 over 2x, so that the constant 3 moves over to the other side, 3 over 2. Okay, so remember it's negative 3 over 2, so when it moves it becomes positive 3 over 2. Okay, and so the fourth step states that we should add to both sides, of the equation, have the coefficient. Okay, this side you need to be very careful. Have the coefficients, okay, of x all squared. All right, in this case, like above, like we have above, the coefficients of x is 5 over 2. 5 over 2. What we mean by the coefficient of x is the number that stands beside x, that's the coefficient of x. Okay, while x is the variable of 5 over 2. S squared, the coefficient of x squared here is 1. Okay, good. But the coefficient of x, that's the one we're interested in, and so we say we should add to have the coefficient of x all squared. Don't worry, I'll still demonstrate that so that you will understand. Okay, and so in this case the half coefficient of x is 5 over 2. Good. And then have the coefficient squared is squared is given as 5 over 2. Dividing it into half is divided by 2, all over 2, and squared is raised to power 2. Okay, which will eventually give us 5 over 2 times 1 over 2 all squared, which is equal to 5 over 4 all squared. Okay, that's fine. And so we proceed to the next step. What the instruction says is that we should add half of the coefficient of x all squared. Okay, half is dividing the coefficient by 2, and all squared is raising to the power of 2 after dividing, and then you have 5 over 4 raised to the power 2, and then we are told to add to both sides. Okay, and then the both sides we have there is x squared, sorry, x plus 5 over 4, okay, raised to the power 2. Okay, so it's like we jump in a step. All right, so thus after carrying out this instruction, we have x squared, and then we add half the coefficient, which is 5 over 4, okay, x, and so plus 5 over 4x, 5 over 4 squared, okay, to be equal to, we add to the other side of the equation, and then we'll have 3 over 2 plus 5 over 4 squared. I hope you do understand this. Okay, suppose you don't. Okay, what we are saying is that half of the coefficient squared, which we are told to obtain, we obtain to be equal to, okay, all right, half the coefficient, half the coefficient of x, okay, all squared, we obtain to be equal to 5 over 4 squared, and we are told to add to both sides of the equation. Remember, the equation was formally given as x squared plus 5 over 2x, all right, to be equal to 3 over 2, and when we add that, we have x squared plus 5 over 2x, and then adding the half coefficient, you have 5 over 4 all squared to be equal to 3 over 2 plus 5 over 4 all squared. Okay, you can see me adding them to both sides, to this side and then to this side. All right, and so at this point we have to do some little mathematical manipulation. All we do here is ordinary to collect the two terms x squared, x plus 5 over 4 all squared to be equal to 3 over 2 plus 5 over 4 all squared. So what we did was to just collect one term from x and then one term from 5 over 4, okay, to make this. Why we did this was because logically it follows, okay, from your rule of difference of two squares, okay, when you want to add right, simply because we know that moving from this point, okay, we can get back to this point. Is understood? Because moving from this point, you have 5 over 4, all right, plus times x, 5 over 4. We are trying to expand to see whether we'll get back to what we have here, what we have in C. Okay, all right. So x times x gives me x squared, and then x times this gives me 5 over 4x. Okay, and then x times this x give me 5 over 4x, and then 5 over 4 times 5 over 4 gives me 5 over 4 all squared. Okay, all right, so I want to add these two values. I have 4 as the LCM here, and I have 5, and then I have 5 again, and so this gives me x squared plus 10x over 4 plus 5 over 4 all squared. And you know, 2 into this can give you that we have this to be x squared in plus 5 over 2x plus 5 over 4 all squared. All right, so this is not actually what we are doing, but then we want to prove that x squared plus 5 over 2x is equal to, is the same thing as saying x plus 5 over 4 all squared. Okay, and so that ends, and then we'll continue from should I call this, you continue from step 1a. Okay, and so from step 1a we have that we've already denoted that this is x plus 5 over 4, okay, all squared to be equal to 3 over 2 of 3 over 2 plus 5 over 4 all squared. All right, at this point you have, or you are done with your manipulations. All you need to do is to take square roots after maybe you have simplified as much as possible, and so here becomes 3 over 2 plus 5 raised to the power 2 is 25, and then 4 raised to the power 2 is 16, and so LCM here is 16. 16 into 2 is 8. 8 times 3 is 24, and then 16 into this is 16, then you have 25. All right, and then the next step follows that x plus 5 over 4 is equal to, right, 49 over 16, okay, all squared. Right, so at this point, like I said, all you need to do is to take square root of both sides. If you take square root of both sides, so this gives you square root of x in the bracket of 5 plus 4 all squared, and then the 2 takes care of the square root, and then on this part we have square root of 49 all over square root of 16. Good. So that on the next slide you have that x plus 5 over 4 is equal to square root of 49 is 7, and then square root of 16 is 4. Alright, so at the point where you take the square root, the equation changes to x plus or minus 5 over 4 equal to 7 over 4. Okay, and so that x will now be equal to 7 over 4 plus minus 5 over 4. Okay, so that x will be equal to 7 over 4 plus 5 over 4, or x will be equal to 7 over 4 minus 5 over 4. Alright, let's try to work out the two. X for this part becomes 4, and then we have 7 plus 5, okay, and which gives us or x becomes, at this point you have 7 minus 5 is 2 over 4, okay, which is equal to half, 1 over 2, and then from this point we have x, this is 12 over 4, okay, so that x is equal to 3. So therefore we can say that x is equal to 3, or x is equal to 1 over 2. Okay, so this is by the use of our formula method. We may solve one more example. By using the formula method, and then after the example we will go into the use of completing the square by the use of formula methods. Sorry, so this is the use of completing the square method for solving quadratic equations. All right, let's take another example. Example 2. Okay, we'll use one of the examples we did previously. Okay, but I can use any other example. Example 2. Find the roots for the equation. Find the root for the equation 5x squared, right, minus 8x plus 2 is equal to 0. Okay, using the completing the square method. Alright, so remember what we said. Solution, the first step is for you to observe very well. Look at the equations and then observe. Okay, you find out that all the equations are on the same side. Okay, the next step is to make s squared unit 3, and to make s squared unit 3 we divide all sides by 5, and x over 5, and then 2 over 5, okay, equal to 0. And the third step is to collect like term, put all the x's in one place, and then push the constant to the other side of the fraction. And then you have 5s squared over 5 minus 8 over 5x, okay, to be equal to minus 2 over 5. You know, it's becoming minus 2 over 5 because it's crossing an equality sign. Alright, and so the next step is to take half the coefficient of x squared and then add it to both sides. Right, the coefficient of x squared here is 8 over 5. Okay, taking half the coefficient of x squared is dividing it by 2, and then squaring it is, okay, squared. Alright, so dividing it by 2 is as good as saying 8 over 10, 8 over 5 times 1 over 2 all squared. Okay, so that from this point we have that 8 over 10 all squared, and 8 over 10 can as well be written as 4 over 5 all squared. Alright, so we add 4 over 5 squared to both sides of the equation. Alright, sorry, I think when we make this unit 3, this becomes x squared minus 8 over 5 x equal to minus 2 over 5. Alright, so adding half the coefficient to both sides, okay, we have x squared minus 8 over 5, sorry, yeah, minus 8 over 5x, and then adding the half the quotient 4 over 5 all squared to both sides, and this side have 2 over 5 plus 4 over 5 all squared. Right, x squared minus 8 over 5x, okay, and plus 4 over 2, all right, so plus 4 over 5 squared plus 4 over 5 all squared is equal to minus 2 over 5 minus 2 over 5 plus 4 over 5 all squared. All right, so remember what we did to the last bracket, so you can as well say x plus 4 over 5 all squared. Okay, we'll get us back to that bracket there. Okay, and this side becomes minus 2 over 5 plus 4 squared is 16, 5 squared is 25, right? And so x plus 4 over 5 all squared is equal to, and minus 2 over 5 plus 16 over 25. Then we take the LCM here, which gives us 25. Then 5 divided by 5 gives you 5. 5 times this minus 10 plus 25 divided by this, okay, 16. Okay, then we have 16 minus 10 plus 16, which gives 6 over 25. All right, and so at this point we have that x plus 4 over 5 all raised to the power 2 is equal to 6 over 25. Okay, so that when we take square root of both sides, okay, square root can take care of this root, and then we have x plus 4 over 5, okay, to be equal to square root of 6 over 5, because square root of 25 is 5. So that x will be equal to root 6 over 5 plus minus 4 over 5. Okay, so therefore we mean that x is equal to root 6 plus 4 over 5, or x is equal to root 6 plus minus 4 all divided by 5. Okay, so you can use your calculators to evaluate this, and so it's not that difficult. You can use your calculators to evaluate this. All right, the value for root 6 is equal to 2.45, right? But root 6 is equal to 2.45, and so s is equal to 2.45 plus 4 over 5, or x is equal to 2.45 minus 4 over 5. Okay, so that we can get point values, and so you have 2.45 plus 4 divided by 2 by 5 is 1.29, or x is equal to 2.45 minus 4, and then divided by 5 we have 0.31 minus 0.31. all right, so these are the roots of the equations using the completing the square method for quadratic equations. So we'll go ahead to use completing the square method to derive the almighty formula, the formula method. Okay, using the completing square method to derive the almighty formula, or the formula method. Okay, so ordinarily a quadratic equation is defined as an equation ax plus bx plus c equal to 0. all right, and we are using the completing the square method to solve this. Okay, completing the square method to solve this, we solve as follows. We have that the first thing we do is to make x squared unitary, have ax over a plus bx over a plus c over a equal to 0 over a. Okay, so this takes out a, and then we have x squared plus b over a of x plus c over a is equal to 0. Okay, and the next thing is, by this step, the next thing is to separate them. We have x squared plus b over a. All right, I'm trying to factorize, and then I push c over a to the other side of the equation. It becomes negative c over a. Okay, and then at this point I take half the coefficients of x, half the coefficients of x all squared. All right, and the coefficient of x on this line is b over a, and I have it, that's dividing it by 2, and then square it, which I can as well write as b over a times 1 over 2 all squared, which is equal to b over 2a all squared. Okay, I add b over 2a to both sides of the equation, and then I have b over a of x plus b over 2a all squared to be equal to minus c over a plus b over 2a all squared. All right, and so remember what we'll do when we get to this point. We always pick one variable x here, and then we always pick one from this part, 2a, and then square the both sides, because expanding this bracket gets us back to this. We've illustrated that previously, and so you have minus c over a plus b over 2a. All right, all squared. I think you're adding squares of the equation, all squared, and then we have x plus b over a, right, 2a all squared to be equal to minus c over a plus b over 2a all squared. And so at this point, after carrying out some more simplifications, we try to take square root minus c over a plus b squared. If you square 2a, you have square root of 2 is 4, square of a is a squared, and so we have that. Trying to add them, LCM here is 4a squared, and then 4a squared into this is 4ac minus 4ac, because 4a squared divided by a is 4a, and then 4a times c is equal to minus 4ac, and then at this point 4a divided by 4a squared is 1 times b squared is b squared. Okay, and so therefore we can say that x plus b over 2a all squared is equal to minus 4ac plus b squared over 4a squared. So at this point we can take square roots, of both sides. If we take square root of these, 2 cancels out the square root, and so we have x plus b over 2a, all right, to be equal to, taking square root of this is as good as saying root of minus 4ac plus b squared, okay, all over square root of 4a squared. Okay, and so since the numerator will be difficult to find the square root, so we leave it in the square root symbol, and then for the denominator we can easily find out square root. Okay, the square root of 4 is 2, and the square root of a squared is a. All right, and so we have that x plus b over 2a is equal to square root of minus 4ac, right, plus b squared, then all over 2a. We can cross to both sides of the equation. We've taken our square root to be equal to this crosses the equality sign, and it becomes square root of minus 4ac plus b squared, okay, and a plus minus b over 2a. All right, okay, the common denominator here is 2, and so sorry, the common denominator here is 2a, and so we can write this as square root of minus 4ac plus b squared, and then plus minus b. Okay, therefore x is equal to b plus minus this, and yeah, it's not far from your completing a square method, sorry, from your almighty formula, which says that x is equal to b plus minus 4ac plus b squared all over 2a. It's the same thing. So this is how the almighty formula, or the formula method, is derived. Okay, so this gives a formula for solving quadratic equations. Okay, this is our almighty formula. Okay, as pronounced by some students, or we can call it the formula method. The formula method, and that's the formula you have there. And so we will apply the formula method to the last example we did and see whether there are differences or whether there are similarities, or whether we are actually right or wrong. And so using the formula method, we'll solve two examples using the formula method. All right, solve the following equations. Solve the following equations. All right, number one, we try to get equations that we can solve. Okay, number one, we'll have that from the last example, 5x squared minus 8x plus 2 is equal to 0. And remember, this follows that from your ax squared plus bx plus c, all right, that from here, from this equation given that a is equal to 5, and then b is equal to minus 8, and then c is equal to 2. Okay, just try to relate the constants here to look to be the ABCD we have here. So that's how we use to solve them using the formula method. And then I will be solving for another question 2 we have studied previously, x squared plus 2x minus 8 is equal to 0. Okay, and the same analogy here too, you have that a for this is equal to 1 because the coefficient of x squared, which we call a, is 1. Okay, and that's why it's not written 1x squared. And then b here is equal to 2, and then c is equal to minus 8. So I'm solving by formula. All right, we have that solution A, or solution number 1. Okay, we will have 5x squared minus 8x plus 2 to be equal to 0. Okay, we have solution 1 that given the formula that, remember, by formula method, the formula is defined that x is equal to b plus minus square root of minus 4ac plus b squared, okay, all over 2a, right? And so we have to replace, which is equal to b for solution 1 is minus 8 plus minus the square root sign, minus for a is 5, and then c is 2, and then b is minus 8, that's minus 8 squared, that's b squared, all over 2, a is 5. Okay, from this point we have minus 8 plus minus square root of 4 times 5 is 20, 20 times 4, sorry, 20 times 2 is 40, so we have minus 40 here, and then minus 8 times minus 8 will give us positive value, because minus minus takes care of the both minus sign, and then 8 times 8 is 64. okay, and then all divided by 2 times 5, which is 10. All right, so we can solve further from this point. Have minus 8 plus minus 40 plus 60 will give us 24. So under root you have 24, and then all divided by 10. And it seems that we cannot get right, we'll still check for square root of 24. So at this point, x is equal to minus 8 plus minus square root of 24. It's not a perfect root, so we have 4.89. Okay, so 4.90. Okay, 8997. So we can write as we can translate as 4.90 all over 10. All right, so from this point we have that x is equal to minus 8 plus 4.8990 over 10, or that x is equal to minus 8 minus 4.8990 over 10. All right, from this point, if you do your computations very well with your calculator, you have minus 8 plus 4.8990. all right, you will have minus 3.101 divided by 10, or for this side with your computations, you have minus 8 minus 4.8990, okay, to be equal to minus 12.899 all over 10, and dividing by 10, you will have 1.2 negative. X is equal to minus 1.29, and then for this, when you divide on 3.101 by 10, you have 0.31 minus 0.31. okay, let's see if we had the same thing. Wow, okay, for this value we had the same thing, minus 0.31, but then for this we had a different outcome. Maybe we need to check back and see whether there are mix-up, but I'm happy that we have similar thing at the end point. So you see, the formula method too can be used to resolve equations of this kind. Okay, and then we use the same formula method to solve for example 2. We use the same formula method to solve for example 2. All right, and for example 2, I can say solution number 2. Solution 2. All right, solution 2, we have that x squared plus 2x minus 8 is equal to 0. X squared plus 2x minus 8 is equal to 0. And then we use a formula method to solve it. I think it's better we use the next page to make it look bolder and better. All right, x squared plus 2x minus 8 is equal to 0. And by formula method, you have that for this you have that a is equal to 1, b is equal to 2, and c is equal to minus 8 not 18. all right, minus 8, c is equal to minus 8. And so by formula method, you have that x is equal to b plus minus square root of b squared minus 4ac. I can rearrange my equations the way I like, but just get conversant to one method of memorizing the equation. And so this implies that b, which is 2 plus minus square root of b squared, which is 2 squared minus 4, a is 1, and c is 8. okay, sorry, minus 8, good, all over 2a. A is 1, fine. X is equal to 2 plus minus, right, and have square root of 2 squared is 4, minus 4 times 1 is 4, and then 4 times minus 8 is minus changes this to plus, and then 4 times 8 is 32. I think that's right, fine. all over 2. Okay, and so we add together, and so this gives us 2 plus minus square root of 36, because 4 plus 32 is 36 over 2. X will be equal to 2 plus minus square root of 36 is 6 over 2. Okay, so that this implies that x is equal to 2 plus 6 over 2, or x is equal to 2 minus 6 over 2. And for x equal to 2 plus 6 over 2, which is 8 over 2, or x is equal to minus 4 over 2. And so for x equal to 8 over 2, x here will be equal to 4, or for x equal to minus 4 over 2. Okay, therefore x will be equal to minus 2. So therefore the roots of the equation are x equal to 4 or x equal to minus 2. You can solve by completing the square method, or by factorization method, or by graphical method to confirm that the roots are 4 or 2. Thank you for being part of this class. Keep studying and so high. Good day.